So I want you to think about what the answers would be to this. I want the sine inverse of the square root of 2 over 2 and the arc cosine of the square root of 2 over 2. So we'll just think for a second. Give everybody a chance to think, because you might just know, but other people might need a chance to kind of process what I'm even asking here. So remember that when I was asking the questions before, like when we were just doing sine, cosine, and tangent, your input was an angle measure, your output was a ratio. So now your input is a ratio, your output is an angle, because it's the inverse. We're going the opposite way, right? So you have to ask yourself, like, just like if I said the square root of 25, which I know you know what that is, but like the way you think about the square roots is like what number times itself would give me that number, right? So you can ask yourself, what angle would give me a sine value of the square root of 2 over 2? What is it? Pi over 4, okay. And what angle would give me a cosine value of square root of 2 over 2? Pi over 4 again, right? Just pi fourths. They both have the same answer here? Right? We're going to get there. All right, we all good on that? Okay, so now I'm going to change this just a little bit, and I'm going to ask you, instead of square root of 2 over 2, I'm going to make these negative square root of 2 over 2. Okay? So the sine inverse of a negative square root of 2 over 2. Is it still pi? It is negative pi fourths. Okay? Right, because sine and cosine are both positive in the first quadrant. So we know pi fourths is not the answer to either one of these, right? But the arc cosine of negative square root of 2 over 2, what is it? 3 pi fourths. Okay, because if you remember that when we get these answers, now I could give you an infinite amount of angles that I could say the sine of this angle, as long as my reference was, pi fourths and it was a positive one, would give me square root of 2 over 2. There's an infinite amount I can put in. But when you go the opposite way and you're doing the inverse, there is only one output. Although multiple things could give me a negative square root of 2 over 2, only one is going to give me that negative pi fourths when you do the inverse, because for sine, you have to be restricted to the first quadrant and the fourth. And when I'm doing these quadrants, that is different than these quadrants. Do we understand that? This is the unit circle. This is like the sine graph. Two completely different graphs. When I'm talking about positive and negative here, those are your angle, or that's, your trig values that are not the same as this. So this is talking unit circle. Right? Sine is positive in the first quadrant and negative in the fourth quadrant. So the outputs you get from a sine inverse have to fall in the range from negative pi halves to pi halves. Those are your only options. Okay? I can't even say 7 pi fourths. The sine of 7 pi fourths is negative square root of 2 over 2, right? But the output when you do the inverse is restricted to that, because if it's not, then you don't have a function, okay? It's not a function, because the inverse of sine, because sine keeps going, right? It's going to keep going like this and keep going like this. So if I didn't do that, then it's going to look like this, right? That would be the inverse if I did it. And that's not a function. That's why you have to restrict it, so we don't get all of those angle measures there. It can only go from negative pi halves to pi halves. And cosine is positive in the first quadrant, negative in the second quadrant, so we go from 0 to pi. So all of your outputs for cosine inverse or arc cosine are all positive, because it has to come from the first or second quadrant of the unit circle. Okay? Now this takes a little bit more time to kind of marinate in your brain, but it'll get there, I promise. Okay? Yes. For sine and tangent, if your input is negative, for sine and tangent inverse, if your input is negative, your output is negative. For arc cosine, if your input is negative, your output's in the second quadrant. Going the other way, taking the sine, cosine, and tangent, if your input is negative, it has no bearing on your output whatsoever, okay? Because it's the quadrant that makes the difference then. Does that make sense? We good? Okay, this gets better. It's just like with anything else, because all this stuff was weird at the beginning. And so just like with anything else, it's going to take some practice, and we'll get there. So let's see, this is going on 113. So we're going to redraw some stuff up here at the front to kind of go through that again before we start graphing. Okay, so we're going to start with sine of x. Not the sine inverse, just the sine of x. Okay? And to sketch that parent function when we were graphing, we would sketch this part knowing that it kept going, right? There's still arrows here, even though we wouldn't necessarily draw the arrows if we were sketching the parent function, but I want you to do that here because we need to think about these things. And we knew that when we did our little, like our fettuccine graphs, our x-axis was our angle. So this went from 0 to 2 pi. And our y values went from -1 to 1. Okay, we all good with that? And when you take the inverse of any function, you're exchanging x and y, which means the x and y axis, their units change as well. So when we go to sine inverse of x, right, and that little graph looks like this, and there are not arrows here, it stops, because if it doesn't stop, then it's not going to pass the vertical line test anymore. So x and y switched places, so did the units on the axes, which means that now the x-axis goes from -1 to 1. Your y-axis are your angles, and for inverse it goes from -pi/2 to pi/2. That's why you can't have, that has to be in there. That is the only points you get to plot, period, end of story. So I can't put 7 pi/4 on there because it's not there, okay? Does that make sense? A little bit, maybe? Okay, so then let's look at cosine. So cosine of x, what we would draw for the parent function would look something like that. Our y values go from -1 to 1 and from 0 to 2 pi. But again, that was just the parent function part because really the function itself continued on. We just didn't necessarily have to graph all that. For cosine inverse of x, then we would graph this. And again, these are points here. They are not arrows. So you can see from the graph that all of your outputs, all of your y values for cosine inverse have to be positive numbers or 0, right? Because then here, you've got, this goes from -1 to 1, and your y values go from 0 to pi. You're not going to get a negative answer from a cosine inverse. Questions at this point? All right, so then we have tangent. So the tangent of x. Now for the, I'm not going to draw what we drew for the parent function because we drew it in pieces for reasons that helped with graphing, but I'll just get this one period in here for tangent. And so this, the y's go from -infinity to infinity, and then the asymptotes are at -pi/2 to pi/2. Okay, that's tangent itself. So then tangent inverse, we are exchanging x and y. So here are my asymptotes. They are now horizontal. And my graph looks like this, which means my x values now go from -infinity to infinity. And the asymptotes are at -pi/2 and pi/2. This isn't any different than when you were doing right triangle trig. When you are looking for an angle measure and you're doing SOHCAHTOA and you have the adjacent and the opposite, so you do tangent of theta equals whatever the opposite over the adjacent is, then to get theta, you take the tangent inverse, right? A tangent inverse, a cosine, sine, a trig inverse gives you an angle measure. Otherwise, the angle measure is the input and you get the ratio, okay? Just like with every other parent function ever, you have to know what the shape of it looks like in your brain. You have to. Just like with these, you have to know what these look like so that you can go and do the transformations. Same thing here. So you have to know what sine, cosine, and tangent inverse look like so you can sketch that so that you can do the rest. This is going to be a piece of cake if you know what they look like. But if you don't know what they look like and you can't reason through which way the axes go, then you're stuck. Otherwise, the rest of it's easy. You can ignore all the words on this paper, the rest of the paper, except for where it tells you to graph. Because we are not going by these instructions. This is ridiculous and weird and confusing and totally and completely unnecessary. Just like with the rest of the graphing, what's really important to you is the sketching of the graph and the transformations. Knowing if it's concave up or concave down, if it's positive or negative, where it moves to, things like that. If you need a specific value on any of these, I mean, you can figure it out if you need to, but these tables here are pointless. Whether you're using a calculator or not, there's no need to do any of this. It's all just easy. Okay, if you know how to do transformations, and we've done a ton, you've been doing them since Algebra 1. We've done a lot together already. Most of you do okay on those things. Hang on, this is being weird. So let's just see if we can get through these, and my board is slow. Hang on. I'm starting on the front. I just had to turn the page and turn it back. Okay, so again, don't even worry about those instructions, what those instructions say. We don't care about this either. Even on the homework, there'll be a table there. You just completely ignore it. All we care about, and we're not finding the inverse of the function. We have the inverse right there. This is what we're graphing. And just like with every graph we've ever done, except for sine, cosine, and tangent, when we did those, the A turned into an amplitude and the B turned into the period thing, right? But it still had the same effect that A and B always has. Here we don't have amplitude or period. You're using A, B, C, and D just like you did for every other transformation ever. I didn't mean to make that look like a trig graph either, because that might be confusing. Okay. What is this? A, B, C, or D? Okay. I don't even care what the letter is. What does it do? Is that your horizontal or vertical? Is it a stretch? It's a horizontal what? Compression, because the X lies, right? It's B. Honestly, knowing the letter doesn't even matter. That's why I said never mind. But as long as you know it's a horizontal compression, that's what really matters. So we have I thought you were saying D, and that's why I was. Horizontal compression of what? 1/2, because X lies, right? So then your sine graph, or your arc sine graph, sorry, looks like this, right? You don't have to like put on the X, the pi's and whatever. That's the shape that you have, and then hopefully we know what's happening. If I have a horizontal compression, there are no translations or anything anywhere. Does 0, 0 change? No, so it's still 0, 0. This point here would be at 1 pi halves, right? So instead of at 1 pi halves, I have a horizontal compression of 1/2, so that 1 turns into a 1/2. That's my point right there. This point would be -1, negative pi halves. So instead it's at -1/2, negative pi halves. Those are my 3 anchor points, and I sketch in that piece. No arrows, they are points, because that is literally all the graph is. That's it. Because if it keeps going, it doesn't keep going. It kind of looks like a cubic, but that's not what's happening. It would curve back this way and do this along the axis. Okay? But that would make it not a function then. We good? Easy enough? Okay, let's look at number 2. Yeah, the table, you don't need it. Oh, I do need to see what the function is though. There we go. So this is all we care about right here. So the cosine inverse of x minus pi. So what's the transformation that's happening here? We go down pi. If there were parentheses here, they would, but it's not. So it's down. So we're going to go down pi. This is cosine. So remember, you have to know what the cosine inverse function looks like. Looks like that. So this first point right here would be at 1, 0. Right? So at 1, 0, but I go down pi, so I'm here at 1, negative pi. This point right here would be at 0 pi halves, so I just go down pi. This would be at -1 pi, so I go down pi, and I'm just at -1, 0, and it looks like this. And that's it. Points on the end, not arrows. Everybody okay with all that? Easy enough? It really is that easy. There's no trick or anything. Let's look at the next one. Let's do a tangent. Again, the tables and stuff, there'll be tables on the homework too. Just ignore them, because I'd already copied it and before I decided to take them off. What's the transformation that's happening on number 3? Left 2. So I'm going to the left 2, and this is arctangent, so it looks like this. This one does have arrows, because tangent's different than the rest. All right, so if all I'm doing is moving to the left 2, this 0, 0, it was a 0, 0, but it moves to the left 2, and I'm right here. Does this transformation affect my asymptotes? No, the only thing that would affect them is if there is a vertical stretch or compression, or if there's a vertical shift. So I can still put those in here at pi halves and negative pi halves, but I still have 2 more points I have to plot. If I hadn't translated this, then I would have a point at 1, what? What gives you a tangent value of 1? Pi fourths. So it'd be at 1 pi fourths, but then I have to move to the left 2. And then I'd be at negative 1 negative pi fourths, but I move to the left 2. There's my 3 points, so I can get this sketched in here like so. Okay, see how easy that is? Ask me questions if you have them. Just as I said, see how easy that is. If you ask me a question, that doesn't mean you're stupid, so don't be afraid to speak up. What? You always look like guilty of something. I don't know what it is. Okay. All right, so y'all try number 4. And I'll do it up here too after you get started, but don't look at mine until you're done. I don't want to just do it for you. Remember that X lies. Good job. Yes. All right. If you got this one, if you don't have any questions, go ahead and work on the next 2. And I'm going to, I'll put them up here in just a minute also so you can check, but don't look at mine until you're done. Okay, so I have 5 and 6 done. Don't cheat and look at mine before you're done. Otherwise, it's just me doing everything. But make sure that we agree. No question? Yes. Yeah, so the question is, did you do your horizontal compression before the translation? And the answer is yes. You always leave your translations to last. Think about it as the order of operations, right? You always, well, it's kind of the reverse of the order of operations, but say, please excuse my dear Aunt Sally. No, it's not. This is the same. I have to say it in my head. But you always do the multiply and divide before you do the add and subtract. Okay? So do anything that's multiplying and dividing, and that stuff, the order doesn't really matter. And then you do your other stuff. That's a good question. Anything else? Okay, on the assignment, there's 2 things that you have to fix that I didn't notice. So if you'll grab that, even if you're not done with these, I'll put this back up here, but I want to make sure that you fix the assignment. First, it's the graphing one that's something weird. It's because I moved something and then it didn't, everything didn't move. Everything doesn't always move like it's supposed to. On number 2, the subtraction sign is like mixed in with the line. You can't even see it because it didn't move down. So this should be minus 3 pi fourths on number 2. And number 4, the fraction you can't read because the 2 and the pi are on top of each other, it should be plus pi halves. There's only 4 graphs. There's not a back. That's not a mistake. They should be fairly simple. Ignore the tables. Just graph them. Write what the transformations are, sketch your little picture, and get the thing done. Okay? And then the other piece of paper that I gave you, that's those 20 questions. That's going to be like what the quiz is tomorrow that you just need some practice on. It really, even though there's 20, it shouldn't take you long once you get the hang of it. Okay? So I'll put the others back up there if you need to look at it. And if you have any questions, let me know.